You can simulate any automated process using the RoboDK simulator. When the simulation works the way you want, you can use RoboDK for offline programming and easily generate the robot programs appropriate for your robot controller. This video shows how to build a simulation with 2 robots and a conveyor belt in 20 minutes from scratch. After watching this video, you'll be able to build the conveyor sample station. We can double-click the Start Simulation program to see the final result. As we can see, there are 2 universal robots with the RobotiQ gripper. One robot feeds the conveyor and the other robot takes the parts from the conveyor. We can use the spacebar to accelerate the simulation. We can also press the escape key to stop the simulation. The second robot grabs the part from the target called getConveyor. This wait is simulated by a Python script called waitForPart. This script uses the RoboDK API to constantly check the presence of objects close to this target. This makes the robot wait until a part is present. The Simulate Tool Open program simulates opening and closing the gripper by constantly checking attached objects to the robot grippers. Finally, the conveyor is simulated by another Python script that uses the RoboDK API. We can double-click the Run Conveyor program to simulate the movement of the conveyor. You can model other conveyors by using the same script and updating the conveyor dimensions. We can press the Alt key anytime and we'll be able to move any reference frame, target, or robot tool. Then we can replay the simulation to see the result. Let's get started. We can start by opening the online library. You'll find a large selection of robots and tools in RoboDK's online library. You can sort the library by type, brand, and robot axes. In this case, we'll first add a conveyor and a table object. Then we'll add 2 universal robots as well as 2 RobotiQ grippers. We can add a new reference frame for the table where we'll place the table and the 2 parts. We can drag and drop the objects into the new reference frame. We can rename any object by pressing F2. Robot A will take a part from the table and place it on the conveyor. Robot B will grab parts from the conveyor and put them back on the table. We can use the Alt key again to move the objects with respect to each other. We can also copy-paste the 2 grippers from one robot to the other. We can easily run the program Simulate Gripper. This will automatically hide the tools with the closed tag that are not grabbing anything. We can bring the first robot to an approach position for the table and create a new target. After selecting the robot in the reference frame, we can create a target for that robot on that reference frame. By default, RoboDK will create targets in the joint space. We can change this and make targets in the Cartesian space. We can move any target anytime using the Alt key. If we select the target, the robot will move that target. We can easily show or hide the text on the screen, as well as make the reference frames bigger or smaller using the plus and minus key. If we double-click a robot, the robot panel will open, and we can jog any robot axis by axis. If we don't like the current robot configuration, we can easily change it inside the robot panel. We can repeat the same steps to create an approach target for the conveyor. We can also link the getConveyor and setConveyor targets to their respective robots. Finally, we can repeat the same steps to create the targets for the second robot. We'll rename the targets accordingly using the F2 key. We're now ready to start the robot programs. We can create a main program that will replace all objects into the same place in case we make mistakes. At any time, we can double-click the program to start it. The main program will also start all the simulation events, such as the Python macros, as well as the two robot programs, one to feed the conveyor and the other one to take parts from the conveyor. We'll now focus on making the movement sequence for the first robot, which will take one object from the table and leave it on the conveyor. We'll start by adding a joint movement to the table approach target. We can right-click any object and select Get with Robot to move the robot end effector towards the object, matching the current orientation of the tool. Then, we can create a new target and add a linear movement to that target. Sometimes we'll see a warning message saying that the robot is too close to a singularity. In this case, the joint 5 can't be too close to 0. If this happens, we can move the targets a bit to make sure that the path is far from singularities. We can now add a station event to grab the closest object to the tool. We'll first change the names of the grippers as they're identical for the two robots. Then we can add a quick pause and test the results of the current sequence. Now we only have to add the movements to bring the part to the conveyor and simulate the gripper opening. When we're done, we can run the main program to test the first part of the simulation. If the program was made properly, the robot will put the part on the conveyor and fall to the floor once it reaches the end of the conveyor. What we have left is to simulate the second robot to grab the part from the conveyor. We can follow the same steps that we used for the first robot. The main difference will be that the robot will have to wait for a part to arrive through the conveyor. To simulate this, we can use a call to the program, wait for part. This program blocks the robot movement until a part is close to the target, get conveyor. We assume that there's a presence sensor at the same position where the target, get conveyor is placed. Both robots can share the same target in the table if we use Cartesian targets. We can link the target we used for the first robot to the second robot and move to the target. We'll need a station event to simulate opening the gripper and leaving the part on the table in the same place where we took it. Finally, we can run the main program to test the two robots working together. In this case, we made a mistake and we forgot to simulate taking the part by closing the gripper. We can add a station event to simulate this event and replay the main program. When we're done, we can generate the robot program in a text format that will be understood by the controller. In this case, since we're using a robot from Universal Robots, we need a script program.